Okay. If you look at that question, this is what was given, or what is given. Now, when you check this question, you immediately notice that every equation, all of the equations are lined up well. Now, unlike some practicals where you have to do everything yourself, everything has already been solved for you. So they already gave you gram of solution. That is, solution simply means impure, because when you have mixture, it means impure. Then this one means pure, solute. So what I will simply do here to get my answer is very simple. I will simply say, if I want to find percentage purity, I will simply say percentage purity is equals to mass of pure substance all over mass of impure, or you say solution, mass of solution, or you say mass of impure substance. So once you have a mixture, it's impure, but when the thing is on its own, it's pure. So what you're doing here is just simple. What they just want you to do here is to simply do this thing, this particular gram divided by this gram, times it by 100 times 100. So another way to write this is that it is something as saying mass percentage purity is equals to mass fraction times 100. So I'll simply do 0.005585 all over. Now notice something. I'm supposed to do all over 0.028 gram. But if I do this divided by this, it will simply mean that what I'm doing is actually weight percentage. So since they talked about percentage purity, I'll go to that question. There's a place where they say that the initial mass is 0.5. So I will do, in this case, what I will do is to say times 0.5 then times 100. So which is going to give me 0.005585 divided by 0.5 then times 100. So you're getting around 1.117%. Now if I want to get the weight percent will simply be mass of solutes all over mass of solution times 100. So in that case, I'll simply do 0.005585 all over 0.0278 gram times 100. So if you do this, you should have, let's check, 0.005585 divided by 0.0278 times 100, 20.1%. So this is the weight percentage. This is the percentage purity. So another way to think of it is that percentage purity is equals to mass of pure sample all over initial sample times 100. So mass of pure sample, or you say calculated value all over the initial value, that gives you percentage purity. Why weight percent is simply mass of solutes all over mass of solution times 100. So notice they are almost the same thing, but how you will be able to differentiate it is always check out that thing that you are given. What did they say? Like if they come and say so sample of this is poured into this, that initial sample indicated that place takes over what will be at the denominator. But assuming they gave you mass of impure, no problem. But whenever you're doing weight percentage, you simply need to know that it's going to be dealing with the solutes there, because when you dissolve iron sulphate, the iron 2 ion will become a solute, while the iron sulphate itself with this dot water there that you're seeing is going to be the solution. So that is how we got this. Remember, these are the equations of the reaction. So we have this as an experiment. I'll still put the question there. So these are the measures that they say we should take, but all these things are very confusing. So this is our causal line. So but see how I mapped it out. So when you are doing this practical, you first of all determine the moles of ferrous ions present in your sample. Okay, all these things. Now if you want to do the practical proper, the key practical steps to take is to first of all, remember this is the equation of the practical first of all. So if I know this, in order to do this practical well, what I will do is to outline these steps. So I weigh no mass of ferrous sulphate sample. You know, in the question they've already given us everything, but the situation where they did not give us the grams. So we need to take note of all these things. So what I will simply do here is to come and say I have weigh known mass of sulphate. Accurately weigh this. I'm doing the practical up to number 3. Dissolve, titrate. You are doing the practical. Now calculate the moles of KMNO4 used. So that is what I did here. So they gave us calculate the moles of KM using concentration, and you know that mole is equals to CV, concentration times volume. So that is what I did. Then I converted the milliliter to liter, because liter is the STP for volume. I converted it. Then from the equations of the reaction, notice that this is the part of the balanced ion. Notice that the charge here is the same. 2 times 5, 10, plus 8, 18, minus 1, 17. So you come here, you check it. 3 times 5, 15, plus 2, 17 is balanced. So the equation of the reaction ought to be balanced. So let's go back to the number. The second step. So the stoichiometry. Using the balanced chemical equation between ferrous ions and permanganate ions, calculate the moles of ferrous present in the sample. That is what I did here. So I used it to balance. This is having 1 mole. This permanganate ion is having 1 mole. Why this is having 5 moles? So I put it here. So I have already calculated the mole of the reaction for permanganate, and I got it to be this 2 times 10. So this one I don't know it. So when you cross it, you get this. So now that I've gotten the mole of ion there, ion that is there, I will now need to get its molarity. So let's move to the next step. That is what we did here. So here we said calculate the mass of pure ferrous sulphate. Calculate the mass of pure ferrous sulphate using the moles of ferrous ions. Calculate the mass of pure ferrous sulphate. So I broke all those things down here. So see what I did. I said method pro. So molarity is equals to mole of solutes all over volume of solution. Or you say mole of mole of substance all over volume of substance. So that is what I did here to get the molarity down here. So I did mole of solutes. It gave me this. Volume of solution is this 0.05, because if you check the equation of the reaction, you see that you are having 10 sulphate ion against 2 permanganate. Yeah, welcome there. Against 2 permanganate. So even look here, you see the same thing. 2 permanganate and then 10 of it. So I now gave it here by saying that stoichiometry, using the stoichiometry, 2 mole of permanganate react with 10 moles of iron sulphate. Now, since mole ratio is 2:10, the volume ratio will also be 2:10. So 1 milliliter of KMNO4 will react with 5 milliliter of iron sulphate. So converting the milliliter to liter, I did this and I got this. So that is what I now placed here. So when I did that maths, I got 0.02 molarity as well. That is concentration, and you will see that we are correct. How are we correct? Because if we are having permanganate and this inside the same reaction we are trying to titrate with, so that means that their concentration at this point, for us to have a concentration, you know what concentration is, so it's the same, 0.02. So when we got this concentration, we now said, okay, remembering, going back to this our formula, we say that mole is equals to concentration, molarity. Another name for concentration is molarity times volume. So we can now say that mole is also equals to mass over molar mass equals to CV. So when you make mass subject of the formula, you see that you have CV times molar mass. So that is what we did. Our concentration is 0.02. Our volume is 0.005. Should be yes. And our molar mass, that is molar mass of iron sulphate, check it, is going to give you around 151.908. So this is where we did it. So what we did here is actually C, V, and M, molarity, molar mass, sorry. So using the formula, which is mole equals to CV, then remember that mole is equals to mass over molar mass. So by the time you do it equals to CV, making mass out of the formula, you see that this will cross over to times this. So that is what we did here. So we got it to be 0.01519 gram. So by the time you now do the percentage purity, you notice that there is somewhere they gave us 0.5 as our sample, our initial sample. So divide it with the mass you've gotten. So if you divide it times it by 100, we are getting 3.03816%. So that is because if you solve it ignoring what the lecturer gave, ignoring the masses the lecturer gave, you will get this. But if you solve using the masses the lecturer gave, you will get the other answer we have posted before this one. Thank you. Subscribe.